Good day and welcome to another tutorial today. Today we'll be treating inverse and transpose of matrices. So that's basically what we're doing today. And so let's just move on. What do we mean by an inverse of a matrix? We've always done inverse of something, like the exact opposite of something. But here what we mean by inverse is a matrix. Let's say matrix A, comma B exists. And you can only perform inverse of a matrix on a square matrix. What do I mean by a square matrix? What I mean by a square matrix is a matrix that has its row and column to be equal. That is, the number of rows and the number of columns to be equal. So, and what we mean by an inverse of a matrix is when you have matrix A and B and you multiply them by each other, and you are now getting an identity matrix of same dimension. Then we say, you know, remember when we were talking about this thing at that time, that B multiplied by A, BA now equal to AB. If you remember when we were talking about the properties of matrix at that time, I said something around associative rule. So associative rule almost applies when it comes to inverse of a matrix, but the major difference here is they have equal dimension, and when you multiply them by each other you get an identity matrix. So either you do it A multiplied by B or B multiplied by E, you still get the same thing, which is an identity matrix. So when such a thing happens, we say B is an inverse of A. That is, B is equal to A inverse. So the next question that will be on your mind now is, how do I calculate the inverse of a matrix? I know. So let's move on. But there's another thing for me to mention to you. There's a name we call a matrix that has an inverse, because unfortunately not every matrix possesses an inverse. For example, once a matrix is not a square matrix, then it does not have an inverse. But when they do have inverse, we call such matrix a matrix that has inverse. We call them regular, invertible, or non-singular matrix. So we call A to be regular, or invertible, or non-singular. Sorry, I need to clean this. Non-singular. When they have an inverse, that is when A has an inverse. But when it does not have an inverse, we call them singular or non-invertible. So something like just the opposite. So if it does not have an inverse, that is A does not have an inverse, does not have an inverse, say it is singular or non-invertible. So let's move on to how to calculate the inverse of a matrix now. So moving on to calculating the inverse of a matrix, so what we basically do is this. So let me give you an instance of a matrix. Let's say A equal to 1, 2, 1. This is an example of a matrix inverse. Don't worry, we'll do how to calculate it soon. I know you are more of I'm keeping you in suspense, but I'm not doing that intentionally. I need you to understand some basic concepts before we move on. So the inverse of A is basically this: -7, 6, 2, 1, -1, 4, 5, -4. You are looking at me like, how do you know it's the inverse? So let's multiply them by each other and see what it will give us. So let's multiply, okay, instead of going that long, so let's just zoom this in a bit. Then let's write beside. So let's multiply this by this. So that's AB is now equal to what? So AB is equal to, that's 121 multiplied by minus 724. That's minus 7 plus 4 plus 4 plus 4. That's 1 times minus 7, 2 times 2, 1 times 4. So then, no, this one is minus 7, not 1, minus 7, yeah. Then the next one, I think the space we have here will not contain what we are about to do. So let me just zoom in more. Let me zoom in more. I know it's becoming dull, but I need the space to be enough. So the next one will be this row times minus 715. So that we have minus 7 plus 2 plus 5. Then the next one we have 6 minus 2 minus 4. Then the next one would have this second row here multiplying the first column. That's minus 7 times, 4 times minus 7. That will give us minus 28. Minus 28 plus 4 plus, no, sorry, I've made a mistake. Let me erase what I just did. I've made a mistake. So we have, that's this times this, that's minus 28 plus 8 plus 20. Then the next one is minus 28 plus 4 . Oh, sorry, I made another mistake. Minus 28 plus 4 plus 25. Then the next one is this multiplied by this. That's 4 times 6 will give us 24. Plus, minus 4. Minus 20. Then the next one will be this last line, this last row here multiplying this colon. So 6 times minus 7. 6 times minus 7 should give us, that's 49 minus 7. That will give us 42. So minus 42 minus 42 plus 14 plus, that's 28. Yep, I guess so. Yep, it's correct. Then again, this times this as minus 42 plus 7 plus 7 times 5 is what? Like I expected it to talk. 35. That's that. Then the next one, that's 36 plus, minus 7. Minus 7 times 4 is what? 28. So if you add this together, it will give you, the first one will give you 1, the second one here will give you 0, the third one here will give you 0, this one will give you 0, this one will give you 1, this one will give you 0, this one will give you 0, this one will give you 0, this one will give you 1. So you can see it gave us an identity matrix of dimension 3 by 3. So that's why we said B is an inverse of A. That is, B is now equal to A inverse. So that's inverse for you. So let's quickly move on to transpose. Don't worry, I will show you how to calculate inverse. Don't worry, I will show you how to calculate inverse. Put that at the back of your mind. It might not be in today's tutorial, but I will definitely teach you how to calculate inverse. So transpose. Now, what do I mean by transpose? So basically, When we say the transpose of a matrix, what we mean is like when you flip it on the, what's it called? When you flip it on the main diagonal. When you flip it on the main diagonal, what I mean is, let's say A is an element of this M by N, and B is an element of this. Okay, let me just zoom back out so we can enjoy this better. So we can enjoy it better. So as I was saying, so having all that now, we say B, which is an element of B, equal to AJI. It's just when you flip it, like let's say you have a matrix here, you have A, B, C, D, D, E, F, G, H, I. So when you now flip it, it should now become the transpose. Let's say this X now. This equals X. So X transpose will be equal to, it will now be, all what you have here, you've moved it to this side. That will be A, B, C. You can see what we have on this line. You bring it down here. So A, B, C. Then we have D, E, F. Then you have G, H, I. You now notice something. What we have on the main diagonal here is still what we have on the main diagonal here. So it's something like you flipped it on the main diagonal. So X transpose is equal to X. You are getting me, right? So let's move on to the next one. So let's just talk about some properties of inverse and transposes. So let's basically talk about some properties of inverse and transposes. So here, let me pause this tutorial here. So moving on, we have our number one property. Let me just write it. Properties, important properties. Oh, sorry. Important properties of inverse and transpose. Transposes, as inverses and transposes. So the first one is A multiplied by A inverse is equal to, which is equal to A inverse multiplied by A. I've already mentioned that the other time. So moving on from there, then we have another one, A B inverse is equal to B inverse multiplied by A inverse. You can check all this, so you can just pick up a matrix and try to do all this I'm saying. Then A plus B inverse is not equal to A inverse plus B inverse. Note, not equal to. Then our A transpose, I've mentioned this already too. A transpose is equal to A. Then A plus B transpose is equal to A transpose plus B transpose. Then the next one is, let's say, A plus B transpose. And the next one is A B transpose is equal to B transpose plus B transpose A transpose. So having said that now, let's move on to symmetry of matrices. So when do we say a matrix is symmetric? If we say a matrix is symmetric, let me just write it out. Symmetry. I don't know what you understand by symmetry, but in the first place, symmetric matrices. Symmetric matrix So basically, what I mean by a symmetric matrix is when A is equal to A transpose. That's what we mean by a symmetric matrix. So, and something should be mindful of is, because we say a matrix is symmetric, it simply means some things here. It simply means some things, and it does not imply some other things again. For example, A inverse transpose is equal to A transpose inverse. So you can't see the other part. What I wrote there is this. So if A is invertible, then A transpose and A inverse transpose is still like this, exactly this property that I mentioned here. But the sum of symmetric matrix, that is two symmetric matrix, if you sum them together, their result is not necessarily symmetric, especially when it is not the same matrix that you are multiplying. I mean, you are adding together. Let me just give you an illustration, then we'll close this tutorial because it's already getting long. So let's say you have A to be equal to this 1 0 0 1. You know this is a symmetric matrix. Sorry, 0 0. This is a symmetric matrix. That is when you transpose it, it's still the same thing. So when you transpose it, it's still the same thing. Then you have another matrix, right? You have this 1 1. You know this under symmetric matrix. When you transpose it, it's still the same thing. If you add these two matrices together, if you add them together, what you get, oh sorry, when you multiply them together, sorry, what you get will not be symmetric. When you multiply this together, actually what you get is this. You get 1 1 0 0, which is not symmetric. I don't know if you are getting me. When you multiply this together, it will not give you a symmetric matrix. Let's just do, okay, let's end this tutorial here, and the next tutorial will be very short. That's where we'll treat multiplication by scalar. So till next tutorial, don't forget to subscribe and like this video. See you in the next tutorial. Thank you.